Hello, it's John again with another video, and this video is about the CBM Prg Studio piece of software. Now I've done a couple of videos about this piece of software, and in this video we're going to be talking about the assembler, in specific the Assembler Directives. Now Assembler Directives allows you to tell the assembler how to react or what state to do things, or even just to report in a different manner. Now there are several directive statements inside CBM Prg Studio. The first one I'm going to talk about is the target. Now this allows you to specify to the assembler what the target machine is for the code. So you can write some assembly for, say, the VIC-20 and the Commodore 64, and it could be exactly the same in terms of coding and all that, but there are differences between the two machines. Like, for example, if you want to print a string on the Commodore 64, you would use the routine $AB1E, but the VIC-20 doesn't have that routine. The routine is stored in a different place, and it's stored in $C1BE, C1BE, yeah, because the VIC-20's basic memory is stored in a different location than the VIC. So the 64 basic is stored from A1000 onwards, as the VIC it's C1000 onwards, but it's almost exactly the same, and quite a lot of the routines are stored in exactly the same place, but in exactly the same relative place. So you would use the target machine directives to be able to test what target machine it is and set a variable to be either AB1E or CB1E. This is a very powerful directive, because you could write an assembler program to be used over, for example, 3 machines, the VIC, the C64 and the 128, and all you need to do is change a couple of parameters or variables depending on where the locations are. And it's even more imperative when you are creating a VIC program, because you could be writing something, if you write something for the 3K VIC, the memory locations are different from a 6K VIC or an 8K VIC. So this is a very powerful directive, and we'll do a very simple demonstration of this. The next directive is what the repeat directive, and this allows you to, like a macro, where you can, in a macro you can define a set of logic that then gets inserted into the assembly as and when you call the macro. Well, with the repeat you can actually write a bit of code in between the repeat and the end repeat, tell it exactly how many what number you want to start with and what number you want to end with, and what it's going to increment by, and then use that within the code itself. It's very similar to a for next loop, but it allows you to quickly repeat a block of code many times without having to write it again and again and again and again. And I'll demonstrate this in a quick example later on. The next one is relocate. Now this is a very interesting directive, because you can assemble a program from $1000 onwards, but you really want this program to reside in, say, the memory space C1000 onwards. And the reason why you assemble it into 1000 onwards is because you want to be able to load it in and then move it to C1000 to be hidden away from basic. And the relocate basically fools the assembler that it's assembling in C1000. All the jumps are related to C1000, all the branches and all that are all related to C1000, but it's actually assembled in 1000, and I'll do a quick demo of that one as well. Export, this allows you to export a assembly label from assembler into basic. So for example, if you've got an assembler routine or several assembler routines in your assembler, and you've got a label that defines the start point of each one of those routines. So for example, move cursor left, move cursor right, move cursor up, move cursor down. You could export those 4 labels into basic, and then in basic you could do SYS move cursor up, SYS move cursor down, SYS move cursor right, move cursor left, and it allows you to embed the memory location of those labeled pointers in basic. So you don't have to do SYS blah, you could say poke label comma whatever, poke this label comma whatever, and it's a very powerful tool that allows you that if you're changing your assembly program and the locations change, they automatically get reflected back in the basic program. Watch, this is a directive that I asked Arthur to put in, where in your assembly you can actually specify which labels or variables to watch in the onboard debugger, rather than having to assemble it, fire up the debugger, find where the memory location of that label is, add it to the watch, and then debug it. You can specify inside of the assembly, the assembler file, what variables you want to watch. Very powerful instruction. Debug, this allows you to, when the assembler's running in the output window, you can actually specify what sort of things you want to see in that window when it's doing its pass-throughs. So you could set a message, you could tell it to output a variable on each of the pass, so in each of the passes you can see what it is. You can set tell it to show a label. You can tell it which pass to report this debug information. You can specify whether it automatically lays out the labels and variables for you. You can tell it whether to report in hex or decimal, and you can tell it whether to highlight the debug information in the output window. It's very useful if you're trying to debug an assembler problem rather than coding, so it's just an assembler problem. Operator, well, the operator is where you're doing add, subtract, multiply, and what this does, it allows you to specify whether you're going to use the calculator method, which is that it calculates the answer before it derives the high and low bytes, or you can set it to high and low, which then when you're calculating, it calculates it, first it derives the high and low and then applies the calculation to it. It's very rare that you would do a high-low, but I can see certain situations where you might want to use it. Here's 2 more directives. We got warning, and basically this just turns on and off the warnings when you're doing when you're actually assembling the program. So if you have it on, you'll see the warnings in the error dialog box, and if you turn it off then you won't see them. Warnings don't stop it assembling, it's just nice to see or not to see when you want to assemble. And no load address, this is where you can, I think it's where you can assemble without setting a start address. I'm not too sure about that one, but we can we'll certainly have a look and see what it does. Ink assemb. Now you've seen me use this in previous tutorials, but basically what it allows you to do is if you've got an assembler library and you've got little files with a routine in each one of them, and you want to use that routine in your assembly, you can actually include it into the assemble file that you've got using by the ink assembly statement. And this allows you to make much more targeted assembler files, but allows you to include them into the assembly. And also you can layer it, so you could include an assembler file that has an include in it, and then that could have an include in it. The thing you've got to worry about is if in assembler file 1 you're including assembler file 2, which includes assembler file 3, which that assembler file 3 includes assembler file 1, then you end up with a circular reference and you can cause issues. Inc binary, this allows you to include any binary file, either a typical binary file or a binary file from within the project, so a sprite file, a screen character file, or a character file from within the CBM Studio. Character set directive allows you to specify which is the character set that you're going to be using at that moment in time. So when you're doing text or using screen codes, you can actually set the character set that you want to use. By default it's character set 1. So here we are in CBM Program Studio. We've got ourselves a blank assembly file. So the first thing we're going to do is we're going to test out this the target directive. So the first thing you need to do is tell it what the target is. So I'm going to say the current target is a Commodore 64, and then we're going to put some code in straight out of Arthur's help file that's going to test the target and then produce a string based on that. So it will say hello from your either C64, C16 or VIC-20, and this then is assembled inside the assembler. So we're setting it to be a Commodore 64 and we're testing. If it's a Commodore 64, then put some text in the assembler as C64. If it's a Commodore 16, make it C16. If it's a VIC-20, make it VIC-20, and then add the word computer after it. So if we build this now, and I'm going to build it straight into memory, when you look at the assembler, you'll see that it says target, and then it's putting in the text hello from your Commodore 64 and then computer. But if we change it to VIC-20 and then do a rebuild, you'll notice that in the assembler output it says hello from your VIC-20 computer. So it's actually embedding and assembling a different line of code. And if we change this to C16 and do the same thing, there you go, it's put the C16 line in. And this is very powerful when you want to write one assembler file but for many machines. The next thing we're going to look at is this repeat. So here we go. What I've done is I want to store in this location a matrix of the rows for the screen. So what I'm saying is to repeat starting from 1024 to 2048 in steps of 40, and put the counter or whatever it is between 1024 and steps of 40 into low index. And then I want it to do a word of this low index. So it's going to build me an array of hopefully all the screen locations by row. So if I do it to memory again, and there you go. So this are all the screen locations by row. So 1, 2, 3, and I bet there's a few of them there. 1, 2, 3, 4, 5, 6, 7, 8, 9. Oh, I can't be bothered to count. Oh, no, here. 4 to 29 minus 4 is 25. There you go. 25 rows. That's what's on the C64. But it allows you to build an array, in this particular case, array of screen rows locations. But you could put an awful lot of code in there that if you wanted to say do a delay for 3 times, you could make a repeat that does the delay for 3 times. And that's how this repeat directive works. The next one I'm going to show you is the relocate. Straight out of So here's another example out of Arthur's help file, and basically if we unrem that, we're saying to the assembler we need to put this in memory location 1000, but we want to be able to relocate it to location 3000. So when it assembles it, it will assemble it in location 1000, but all the jumps and the references should be of the series 3000 onwards. So if we build it, and here we are with the assembler output. So as you see, cycle is was assembled at 1002, but when we jump back to cycle, it's jumping back to 3002, and the hello world is assembled into 1011, but when we reference it, it's actually referenced it at 3011, and this allows you can assemble it in 1000, and then you could do a copy from 1000 to, in this particular case, 1000 to from 1000 to 1020, and paste it into 3000, and all the references are set to 3000. If you run this currently, it would fail because it would be looking for 3011 and there's nothing there. We'd have to copy and paste this, and that's what the relocate's all about. So if we get rid of that, now the other thing that we use quite a lot, or I should use, is the inc assemble. And what you do is, in your project file you'll have assemblies. So here we go, tutorial routines. So I'm going to include tutorial routines.asm into this assembly file, but I'm not going to put it there. I'm going to put it at the end. There we go. So when we come to build this, it should import the tut assembly routines. Now there's an error somewhere. 4 errors. We've got 4 errors. Let's do that again. There we go. 4 errors. What are they? Well, there we go. So it's looking for the my constants. Whoops. It's looking for my constants. So let's put that back on. So I need to include my constants file, which is this one here, character ASCII constants, because I'm referencing it. So inc assemble character underscore ASCII constants. Ooh. There we go. I think that's right. Character underscore, yeah. So we should be able to build this now. There we go. So I'm including 2 assembly files now. So there's the main one, and then you'll see here's the character ASCII constants assembly file, and then my tutorial routines, all assembled, included into that file, and then all the variables. So if I close that down, all the assembler variables are here. There you go. Now there's another, so if I get rid of that, there's another interesting thing, and that's the debug messaging. And what you can do is you can put So here I'm saying debug, put a string into the debug window. This one's remmed out. I'm setting the variable automation to be on. I'm telling it to work in decimal, and I'm telling it to highlight the debug stuff, and I want it then to show H window and cycle. Alright. Now this is all going to come out here. So we'll make that big, and then we'll build it. There you go. So there's the assembler stuff and memory. But if you look in the output window, so the first cycle, H world and cycle were zeros. Then there became a value, and then on the third pass, it did it. So it does 3 passes. But you could say, only show me the information on pass 2. So if we do build to memory, so there we go. And this time, it's only done it on pass 2 lot. So pass 1 has done the code, but pass 2 has only shown everything else. And if you don't want to work in decimal, you can tell it to work in hex. So here, do it again. There we go. Scroll up, and there you go. It's now working in hex. And this auto, I'm not sure why you want to turn it off, but we'll do it anyway. All it does is it just shows you the number of the variables that you've asked to look at in the debug window. So you've asked for H word and cycle, and if you turn off the auto, it just gives you the 2 numbers. So I've always kept it on. And highlight on and off is just the red. So if you turn it off, it'll all be blue. But you leave it on, it highlights your debug information. So this is the typical one that I have, is that you only show pass 2 because that's when your normal variables are done, and it's always in hex, always auto highlighted, and then you put your variables in the debug window. So I'm hoping that this has been very useful for you, and that you will use these directives and the other ones as well, but these are the ones I've used the most to help you in your coding of 6502. I'll see you later on the next video. Take care. Bye.